Hi dear students. Okay, so I hope all of you are doing good. Okay, so welcome to today's Brainiacs Capsule. So we are going to discuss the chapter alcohols, phenols and others, and I have selected three important questions for this particular chapter. Okay, and we will try to see these questions in detail and along with some theory. Okay. Yeah, if you have any doubts, feel free to comment on the comment box. So the first question here for you is, go through the question. The question is, which of the following, which of the following methods does not give phenol? Okay, which of the following methods does not give you phenol? So the question is all about the preparation of phenols. So different methods are shown here and we need to analyze which method is not going to give you phenol actually. Okay, so I have explained this in detail. So the first method what they are shown there is actually from chlorobenzene. Okay, we know it's a haloarene. Okay, and we learned in chapter haloalkanes and haloarenes that normally haloarene will not undergo reaction, will undergo very less reaction, or will undergo very less nucleophilic substitution. What is the reason for that? So I am going to explain that first, then I will explain how this reaction happens. So the reason for that here is there are four reasons mentioned in NCERT textbook. Okay, so first thing what they used to say is, so here the lone pair is present. Okay, lone pair, single bond, double bond. So there is a conjugation is there. So what will happen? This will form a double bond here. Automatically this will come to here as a negative charge. So that means this carbon chlorine bond has a partial double bond nature. Okay, it has a partial double bond nature. And also if you see, the next reason can be this carbon is sp2 hybridized. This is sp2 hybridized. Okay, so sp2 hybridization means it has more electronegativity. That means it will pull the electron cloud in this direction automatically. And the other thing we can say here is, when suppose if you are breaking this bond, what will happen, sir? You are going to get a localized carbocation, which is phenyl carbocation, which is highly unstable. So there are 3 to 4 reasons that makes this haloarene less reactive. Okay, now then many students will ask, sir, in haloalkanes and haloarenes we are learning this concept, and in the chapter alcohols you are preparing phenol from this. How it is possible, sir? The reason for that is this thing. You can see here, this is extraordinary condition, that is 643 Kelvin and 200 atmosphere. So it's a very high temperature and it's a very high pressure. Under this situation, this particular haloarene will undergo a mechanism that is called SNAR mechanism, nucleophilic substitution for aromatic compounds. And what will happen? The halogen chlorine would be replaced with ONA. Okay, and further this is hydrolyzed. Hydrolyzed means H plus and OH minus would be there, and Na will go out as NaOH and H plus will come here and phenol is formed. But I will explain also this SNAR mechanism. Some students will ask, sir, whether do we need to learn this or not? Of course you need to learn this, because this is explained in your NCERT textbook under the chapter haloalkanes and haloarenes, especially in the section haloarene. You can see that, but they are not mentioning it is SNAR mechanism, but they have explained the steps very clearly. Okay, so let's see how this happens. Okay, very simple, sir. We can say how SNAR mechanism starts here is, here you have a halogen. Okay, and halogens are electronegative and they have minus I effect, and because of this the electrons will move in the topward direction due to this inductive effect. So when electrons are moving in this direction, what will happen? A negative charge would develop here and a positive charge develops here. Okay, I need to correct it as a positive charge. Sorry, I have maintained here a negative charge. Actually a positive charge develops here, opposite charge. Okay, it's easy to understand. Okay, why a positive charge is coming? Because electrons are negative charge and that is moving towards chlorine. Okay, so positive charge develops here. Okay, so because of this positive charge, it will pull the OH minus. It is pulling the OH minus from where? You have a strong alkali NaOH. We know that it is a strong electrolyte. It will undergo complete ionization and you will get OH minus, which is a strong nucleophile. And this OH minus will try to attack this particular carbon. When OH minus is attacking this carbon or forming a bond, you can see this particular carbon will have now 5 valency. One is this one, another is this one, third one is this one, fourth one is this one, and fifth one is this one. It is having 5 valency. So somehow it will, we know that the loosely held bond is a pi bond. So it will immediately displaces here to form a negative charge like this. You can see here. Okay, now you can see here negative charge, single bond and a double bond is here. So surely again this will move towards this here and this will get repelled here as a negative charge due to resonance. Now negative charge comes here. Again negative charge, single bond and double bond. We know that resonance is there. So negative charge will move towards a pi bond like this. Then here it will form a double bond. Then this will get repelled and come here as a negative charge. So you can see here. As a negative charge it is coming. Now again negative charge here, what it will do? Sir, it will try to come back here. Okay, so it will try to form here as a double bond. It will try to come back here as a double bond. So when it is trying to come back here as a double bond, what it will do? The problem is this carbon again will have when it is coming here as a double bond, again it will have 5 valency. So somebody should move out. And we know that OH is a strong nucleophile where halogens are weak nucleophile. So automatically when this forms a double bond here, the halogen is a very good leaving group. It will move out as Cl minus along with these 2 electrons. It will move out as Cl minus. You can see, I can even make it clear for you here. It will move out as a Cl minus. Okay, it will move out here as a Cl minus, you can see. Okay, now what you are getting, sir? So you are now getting OH here. Actually you got phenol here, but the problem is you have an acid. Phenol is nothing but acidic in nature. So in the medium always the NaOH is a strong alkali. So acid base reaction will happen and it will form a salt, that is sodium phenoxide. Then what you need to do? You need to add a huge amount of water. Huge amount of water is added so that Na again will come back and form NaOH. Okay, and here O minus is there. O minus will get attracted to the H plus of water and forms again phenol. Okay, so that's why it is shown like that. Okay, you can see here that step I have explained here itself. So ONA again treated with water to get back your phenol. So I can clearly say the option 1, it will give you what, sir? Option 1 will give you, surely it will give you phenol. So I can say this is a method of preparation of phenol. Okay, now let's start analyzing the second option. Okay, second option we will analyze it. Okay, so this is the second option where you have phenol and you can see COONA. That's a I can say it's an acid derivative or it's a salt actually, COO minus and Na plus. It is treated with NaOH and calcium oxide. NaOH and calcium oxide. So what is happening here, sir? Okay, so what is happening? I can easily say, listen, this NaOH COONA will move out here as Na2CO3. You can see it will be like this. Na2CO3 would be eliminated. Okay, Na2CO3 would be eliminated and you will get phenol. Okay, so here also I am just correcting one point. So you can remove this. Okay, it is not moving. So maybe I will put some black color. Okay, yeah, I can put some black color here. Okay, you can leave it. You can ignore this. Okay. Okay. Okay, you will get phenol. Okay, so it will be moving out as Na2CO3. Clear? Yeah, somehow it came here, I don't know. I am trying to make it very clear for you. Okay. So Na2CO3 would be eliminated as part of this reaction. Okay, and you are again getting phenol. So I can say that the second one is also a method of preparation of phenol, and you will get phenol from this one. Maybe you can write it here as well. Okay, so yeah. Okay, yeah. So this is also a method of preparation of phenol. So in text, they are giving you all method of preparation. So usually questions may come from there. So you should be clear about the method of preparation of phenol actually. Okay. I hope it is clear. Now let's look at the third option. Third option is a wonderful option. So here you have C6H5 MgBr. This is nothing but our C6H5 MgBr. What it is doing? So when it is hydrolyzed, when it is treated with water, what will happen? This carbon magnesium bond, if you see here, magnesium is a more electropositive element. So when this bond is broken, the electrons will move towards carbon. Why? Because magnesium is electropositive, it will try to repel the electrons, and you will get a localized negative charge here and magnesium with the positive charge. And I can say Grignard reagent is one reagent which will create a carbanion, in the sense carbon carrying negative charge. Okay, now when water is hydrolyzed, you have H plus and OH minus. So we know that opposite charges will attract, so H plus will come and join here. Okay, so that it will turn to benzene. Okay, so it will change to benzene. So I can say that there is no phenol formed in this case. So in this case, so our answer would be, they are asking the question, which of the following will not give you phenol? So the answer should be which one? Option 3 should be my correct answer. Okay, because that is giving you what? That is giving you benzene. That is giving you nothing but benzene, sir. Clear? We will also see the option 4 also, how phenol is obtained from benzene diazonium chloride. We will see that also. Okay, yeah. Let's try to see the fourth option also. Since it's a method of preparation, I thought of explaining it in detail. Now here you have benzene diazonium chloride in front of you. So what is happening when it is hydrolyzed? Here also you get H plus and OH minus. Here Cl minus will get attracted to H plus and you will get HCl. And when heating, then nitrogen with a positive charge is highly unstable. So it will take up this electron, push the electron in this direction and move out as nitrogen gas. So that OH minus will come and attack here. Because electrons, when it is moving in this direction, a positive charge will develop here. So OH minus attacks and you will get phenol. Clear? So I hope you understood this question. So let's go to the next question. Okay, all of you please go through the question. The correct order of decreasing acidity for the compound 1, 2, 3 and 4 is. This is what you need to analyze. Okay, so I will tell you some techniques whenever questions they are asking questions based on acidic strength. Very important actually. Okay, so whenever somebody is asking you questions on acidic strength, what you need to do is you need to follow certain steps actually. Okay, you need to follow certain steps. So before we go to that steps, you need to know who is an acid fundamentally. So who is an acid, sir? Fundamentally, who is an acid? Please remember, this definition is very easy to remember. Okay, in equilibrium we are learning that, but for organic this is sufficient. We can say somebody who can donate H plus. Okay, this is the most commonly used definition. So any organic compound which is capable of donating an H plus is considered as a very good acid. Okay, there are other definitions are there. For example, we can say OH minus acceptor. Acid can be OH minus acceptor also. Okay, and also we can say electron pair acceptor. Acids can be electron pair acceptor. So these are the three popular definitions. But in organic, mainly we are concerned about H plus donation. So whenever you are given a compound, check whether that compound is capable of donating H plus. If that guy is capable of donating H plus, then I can say he is a very good acid. Okay, electron pair acceptors are also known by another name. You may be knowing it. It is called a Lewis acid because Lewis come up with that particular definition. Okay, now let's see the steps. Actually, you are interested in steps. Okay, what you need to do. So the first step whenever you are going to check the acidic strength is remove the H plus. First thing you need to do is remove the H plus connected to electronegative atom. Remove the H plus connected to, okay, electronegative atom. Electronegative atom, because that H plus can only be donated. Okay. Okay, so remove the H plus that is connected to electronegative atom. Very, very important. Okay, we will do this. We will practice this in this question. Okay, don't worry. This is the first step. Now, what is the next step, sir? What is the next step? Check the stability. Check the stability. Check the stability of the remaining structure. Remaining structure means once the H plus is removed, you have a remaining structure that is standing there. You need to check the stability of that structure. That is meant by the second step. Check the stability of the remaining structure. Okay. I can show you examples. Don't worry. So never worry. Okay. Yeah. Check the stability of the remaining structure. Now the third question is, what is the third step? How will you check its stability? So stability can be checked by, stability is checked with two effects. What are the two things we will consider while checking the stability? So I can say we use resonance and inductive effect mainly here. Stability is checked with two effects. So what are the two effects? First thing you will check there is whether resonance is present. Whether resonance is present in that remaining structure, then it is highly stable. If resonance is not there, then we will check whether inductive effect is present. Inductive effect is present. So if these two, or if mainly resonance give you maximum stability, inductive effect will also impart some stability. Okay, these are the steps you need to follow. I hope the steps are clear for you. Now we will analyze the question. Okay, so the first option that is given to you here is what? You are given a compound called parachlorophenol. We need to check whether this is a good acid or not. So I told we need to remove the H plus. So where from H plus needs to be removed? Here hydrogen is there, here hydrogen is there, but all those are connected to carbon. We know that here hydrogen is connected to, only hydrogen connected to electronegative atom is present here, this hydrogen. So we need to remove this hydrogen as H plus. So that means we are assuming that this is moving out as H plus, an acid. So what is remaining here? A negative charge. Now we need to check whether this remaining structure is stable or not. How will you check that? We need to check whether resonance is present. We are analyzing it. Negative charge, single bond, double bond, single bond, double bond. You can easily say there is a conjugation. So I have already drawn resonating structures for that. So first step, this will move to here. Then you will have double bond. Then this will get repelled and negative charge will come here. Then this will again move to here because there is still conjugation. Then this will get repelled and come here as a negative charge. Now you can see here this is getting stabilized also. Why? Because chlorine has minus I effect. And it has this minus I effect is greater than his plus sum effect. Because chlorine has lone pair, this electron can be donated also. But for halogens, please remember minus I effect is more dominant than plus sum effect. Okay, so this negative charge will be pulled in this direction also, making it stable. Why I am saying it is stable? Because when electrons move in this direction, or it is moving then towards the chlorine, then it is getting charge is getting decreased by this chlorine atom. Okay, the charge density present here decreases. When charge density decreases, stability increases. Charge and stability, they are inversely proportional. Very, very important. Now again negative charge moves to in this direction, then this will get repelled here. So the next resonating structure, and finally it will come here, then this will come out here as a negative charge. So that means here through resonance, this negative charge is getting delocalized throughout. So when it is getting delocalized, then I can say this is getting stabilized. Why? Because if charge is stationary, this can be easily attacked by anything that is having an opposite charge. Okay, so when it is getting delocalized, it is getting the whole system is getting stable because the charge is decreasing. The charge density at each position for a moment is decreasing. Okay, so I can say that this is a very good acid somehow. Why? Because the remaining structure is stabilized through resonance. Now let's analyze the next structure where you have CH3 is coming into picture. Now the only difference is again the structure is stabilized by resonance. Okay, no doubt in that. So this is also good acid, but how can its strength be compared to the earlier one where it has chlorine? Now it has CH3. The difference is when CH3 comes at this position, we know that it has plus psi effect. So what it will do? It will repel the electron in this direction and the charge density over here increases. Charge density increases means stability decreases. So I can say that this particular structure is here little bit unstable compared to this one. So I can say that this is a much good acid compared to this one, paramethyl phenol. Okay. Now you have the next option where you have NO2 group is there. So NO2 group has the highest advantage. It has both minus M effect and minus I effect. Okay, so NO2 group, if you see, it has minus M and minus I. So what does that mean actually? That means very simple. Whenever you have here also it is stabilized by resonance, no doubt in that. Here when negative charge comes here, the NO2 due to its minus I effect, it will pull the electron in the downward direction. So charge density over here decreases. And also you can see negative charge, single bond, double bond. So there is an extra conjugation is there. That means this will come out here as a double bond. You can see here in this structure I have shown that. Okay, so here you can see here negative charge, it is coming out here as a double bond. So that means for a moment this is becoming chargeless. There is no charge. That means stability is very high. Understood? So that's the reason when nitro group is connected to this particular stuff, this becomes a very good acid because this is having both minus I and minus M effect, and because of that it is giving extra stability. You can see that extra resonating structure because of NO2. Okay, understood? So I can say this is one of the very good acid compared to the other two. Then finally, they have given in the option methoxy group, OCH3. So OCH3 group is having plus sum effect and minus I effect. But for OCH3 group, this plus sum effect is more stronger compared to minus I. Usually resonance effect is more stronger than inductive, but only for halogens, inductive effect, minus I effect is more strengthier than its plus sum effect. So halogens are exceptional cases. So that's why they can, it's a very big paragraph in NCERT also. You need to remember that. Okay. Yeah. So here let's see for methoxy group, you can see when negative charge comes here, what is happening? The methoxy group, due to its minus I effect, electrons will move in downward direction, but due to its plus sum effect it will push the electron in this direction so that the charge density over here increases. So some students may ask, sir, inductive effect is pulling it in downward direction, plus sum effect is pulling it in the upward direction, so it is getting cancelled. No sir, here plus sum effect is more stronger than inductive. That is the reason I can say this is not that as good acid compared to nitro group. Okay, so we can comparatively say if you compare all the three acid, so when you have minus I and minus M is there, that group when connected to an organic compound, it will have the maximum acidic strength. Next, halogen comes into picture. Why? Because here minus I is dominant because that is pulling the electron more in the downward direction. Next, CH3 group. Here some students may ask, sir, CH3 is pulling up the electron in upward direction and OCH3 is also pulling the electron in the upward direction, making it unstable. Then why CH3 comes first? Here plus sum is a stronger effect. That is the reason electron will move very fast. So very fast in the upward direction means the charge density over there increases and making it highly unstable. That is the reason when OCH3 group is connected to phenol, it is its acidic strength decreases very much drastically. Okay, so I hope I have explained it in a very good way. I hope. Okay, so let's see the answer then. Okay, so I can say the stronger acid from this one is third one. Okay, third one is present here. Okay, then the stronger acid is first one, so next one will come into picture. So first 3, then 1. Here 3, then 1 is coming into picture. Okay, then we have 2 CH3, then finally only OCH3 is coming. So my option for here is 4. Clear? The acidic strength is stronger acid is third one, then first one, then second one, and then fourth one. Okay, so please remember these steps. You can easily follow it and try to, you don't need to draw these structures for exams, just you analyze it and see whether what sort of effect does it has. Okay, so if you have minus M and minus I, that will make it a very stronger acid. Okay, if somebody has plus M, that will make it a very weak acid. But only exception is halogens. For them, the minus I is more dominant over plus M. That is the reason it is coming second. Okay, I hope it is clear for you. Yeah. Now comes to the last question for the day. You can see in the reaction. So there is an ether given. Anisole is the stuff. Anisole. Okay. Then, or methoxybenzene, we can say. That is nothing but anisole. It is treated with HBr and they are asking you what are the products. Okay, so this is a very famous reaction. I will explain you how this occurs. Listen. Now, if you see anisole, you can see the reaction center in this particular compound is oxygen atom. Why? Because oxygen has 2 lone pairs present in that. And when you see HBr, or sometimes they may give HI, the reaction will be the same way it will happen. So it will break like H plus and Br minus. Now you see here lone pair is more and you can see benzene is present. So there is a pi bond is there. All together there is an electron cloud around this compound. And because of that electron cloud, it has a negative charge is present throughout the compound. So it will attract the H plus very first. In the very first step, it will attract the H plus towards the lone pair where the charge density is more. Okay, so what will happen? The lone pair, it will donate its electron to the vacant orbitals of hydrogen and it forms a bond here. When that lone pair is donated, the oxygen will develop a positive charge like this. So what will happen? Oxygen with the positive charge is highly unstable because it is an electronegative atom. Oxygen is an electronegative atom. So when it is getting a positive charge, it will become unstable. So usually the electron or I can say the electron that is shared between oxygen and carbon will move towards oxygen in order to compensate the vacancy. It will shift in this direction because of the deficiency here. A pull will come. And because of that, a negative charge, a partial negative charge is coming because of the temporary electron displacement. And a positive charge will develop here. At this moment, you have the Br minus, which is a nucleophile. It will come and attack the carbon from the backside. So why it is attacking from the backside? So because this is a primary, this is a 1 degree carbon. So it will attack from the, not a 1 degree carbon, it is having less steric hindrance. So because of the 3 hydrogen atom. Okay, so it will attack from the backside and that type of attack is called nucleophilic substitution of order 2. So when it is attacking to this backside carbon and a bond is formed, this carbon will have 5 valency. So it will break this bond, carbon-oxygen bond. Why? Because already electron moved towards oxygen and the bond strength is like this. Okay, so it is almost weak. So it will break like this. And you will get phenol and the electrons will come to vacant orbitals of carbon and the other compound you obtain is CH3Br. Okay, I hope you understood the concept. So the answer here in this case is phenol and CH3Br. I can say option 4 would be my correct answer. Okay, so I hope you have enjoyed today's session. Okay, so if you have any doubt, feel free to ask. We are part of Brainiacs classes and we have a very good crash course coming upward. So we have very few seats available. Those who are interested, those +2 students and any repeaters who find it very difficult or understanding any of the subject, you can contact Brainiacs classes and here the seats are filling up very fast, so you can enroll for crash course if you are interested, or even you can watch our YouTube channel, subscribe the channel. You will get daily capsule. Daily we will discuss the most important questions that is expected for NEET 2024. Thank you.